Download this code from codegive.com, link in the description below. Deep dive into buffer protocol types, issue 593, in Python typing. Python's typing system has evolved significantly to provide more precise and expressive type hints. Issue 593, specifically titled Add Buffer Protocol Support, introduced a crucial enhancement for dealing with the buffer protocol directly within type hints. This allows you to accurately represent and validate code that interacts with memory buffers. This tutorial will guide you through the rationale behind issue 593, the motivation for buffer protocol support, the typing.buffer type hint, related types, practical code examples, and common usage scenarios. 1. The need for buffer protocol support. Before issue 593 and the introduction of typing.buffer, describing the types of objects supporting the buffer protocol in Python typing was challenging and often inaccurate. What is the buffer protocol? The buffer protocol is a mechanism that allows one Python object to expose raw data, usually a contiguous memory region, to another object. This avoids unnecessary data copying, leading to performance improvements, especially when dealing with large data sets, example images, audio, numerical arrays. It's fundamental to how libraries like NumPy, Pillow, and SciPy interact with each other and the underlying system. Limitations of previous approaches. Bytes, byte array, memory view. While these types implement the buffer protocol, they are too restrictive. Many other objects also implement the protocol, example NumPy arrays, certain image formats. Using these types would artificially restrict the allowed input to functions that operate on buffers. Using any would avoid type errors but defeat the purpose of type hinting. You lose all static type checking benefits. Duck typing, implicit relying solely on duck typing, assuming an object supports the required methods, is risky. Type checkers cannot verify if an object truly supports the protocol. Abstract base classes, ABCs. While ABCs like collections.abc.sequence exist, they do not directly represent the buffer protocol itself. Creating custom ABCs was cumbersome and less standardized. 2. Introduction of typing.buffer. Issue 593 proposed and implemented typing.buffer. This new type hint addresses the limitations above by explicitly representing the buffer protocol. It signifies that a function expects an object that supports the buffer protocol. Flexibility. It allows any object implementing the protocol, regardless of its concrete type. Type safety. Type checkers, like MyPy and Pyrite, can now verify that an object passed as a buffer actually supports the protocol. 3. The typing.buffer type hint. In typing, typing.buffer, or simply buffer if imported directly, is a protocol. A protocol defines a set of methods and attributes that a type must implement to be considered a subtype of the protocol. Important. Typing.buffer is not a concrete class that you inherit from. Instead, it describes an interface that a class must satisfy. Example. Explanation. The process_buffer function now correctly indicates that it accepts anything that implements the buffer protocol. The valid usages pass because bytes, byte array, memory view, and NumPy arrays all support the buffer protocol. If you uncomment the process_buffer, data_string, line, a static type checker, example MyPy, will report an error because str does not implement the buffer protocol. 4. Related types and concepts. Asterisk memory view asterisk the memory view object provides a way to access the internal data of an object without copying. It is often used in conjunction with typing.buffer. The memory view itself is a buffer-compatible object, so it can be passed to a function expecting a typing.buffer. Asterisk bytes and byte array asterisk these are concrete types that also implement the buffer protocol. Bytes is immutable, while byte array is mutable. You can treat them as subtypes of typing.buffer. Asterisk types asterisk the types module provides a way to interact with C data structures from Python. Types objects can also expose their memory as buffers and can therefore be used with typing.buffer. Asterisk protocol asterisk typing.buffer is itself defined as a protocol. Protocols in Python typing provide structural subtyping, also known as duck typing. If a type has the necessary attributes/methods, it's considered a subtype of the protocol, regardless of explicit inheritance. 5. More detailed examples. 5.1. Working with image data. Explanation asterisk. 1. We use image.image from the Pillow library to load an image. 2. Get_pixel_data returns the raw pixel data of the image as a byte string, conforming to typing.buffer. 3. Process_image_buffer takes the buffer and can then perform direct memory operations on the image data. We create a memory view to access the raw bytes efficiently. 5.2. Working with NumPy arrays. Explanation asterisk. 1. The process_numpy_buffer function accepts a buffer as input, allowing it to work with the underlying memory of the NumPy array. 2. The np.fromBuffer function demonstrates converting the buffer back into a NumPy array. 3. We can access and process the buffer information, size, format, through the memory view. 5.3. Working with types. Explanation asterisk. 1. We define a simple C structure using types. 2. The process_types_buffer function accepts a buffer that represents the memory layout of the types structure. 6. Practical scenarios and benefits. Asterisk performance optimization asterisk typing.buffer is particularly valuable when you're working with large datasets or performance-critical code where minimizing data copying is essential. Asterisk interoperability asterisk it enables better interoperability between different libraries and modules that rely on the buffer protocol. Asterisk clearer type hints asterisk using typing.buffer makes your type hints more accurate and informative, improving code readability and maintainability. Asterisk static analysis and error detection asterisk type checkers can now enforce buffer protocol compliance, catching potential errors at compile time. 7. Caveats and best practices. Asterisk mutability asterisk be aware that modifying the contents of a buffer through a memory view can have side effects, especially if the underlying object is mutable, example byte array, a NumPy array. If you need to modify the data without affecting the original object, create a copy. Asterisk format attribute asterisk the format attribute of the memory view, example b, I, f, indicates the data type of the elements in the buffer. You'll often need to know this format to correctly interpret and manipulate the data. NumPy arrays, for example, clearly define their type, which corresponds to the buffer format. Asterisk buffer ownership asterisk be mindful of buffer ownership and lifetime. The buffer protocol does not guarantee that the underlying data will remain valid indefinitely. The owning object can deallocate the memory. Use context managers or appropriate mechanisms to manage the buffer's lifetime. Asterisk read-only buffers asterisk some buffers may be read-only. Attempting to modify them will raise an exception. Use memoryview.read-only to check if a buffer is read-only. 8. Summary. Typing.buffer is a significant addition to Python's typing system, providing a standard way to represent and validate objects that support the buffer protocol. By using typing.buffer, you can write more precise, maintainable, and performant code, especially when working with libraries like NumPy, Pillow, and SciPy that heavily rely on the buffer protocol. Remember to be aware of buffer mutability, ownership, and the data format to effectively utilize buffers in your applications. Remember to install typing extensions in older Python versions, 3.8, if needed. This will help improve the accuracy of your code and catch type-related errors early in the development process.